So this video is just supposed to serve as a sort of like introduction to circle problems on the SAT. For anyone who may not be super familiar with them, they can be, among the all weirder looking problems, but uh, they're never super difficult, and especially on the new SAT, they have become much easier to solve because the graphing calculator is frankly just much more powerful than what most kids were testing with beforehand. So I just want to give you an example of a basic equation, and I will go over how you can evaluate this on Desmos as well. But I do think it's pretty important to know the basic steps as well as you're going through, because without like knowing the basic steps, there are difficult problems that can come up where it may not be solvable solely through Desmos. Like for example, they can add a constant like this, and usually that is not going to be easy to evaluate using Desmos, and you're gonna have to you're really gonna have to understand exactly what the question means to do this. So the first step we're gonna do, and let's say this question is, you're given this equation and you're asked what is the radius and the center of the circle, right? So we want to know the radius, and we'll call the center C just to be perfectly confusing. Okay, so we should know, or you should be familiar, and if not, hopefully this is just review of the general form of a circle, and it's given something like this. So we have x minus h squared, y minus k squared equals r squared. Okay, where hk is the coordinates of the center of the circle, and r is the radius of the circle. Okay, so we really want to convert this into this form. And the way we would do that is by completing the square for x and for y. Now, if you're not comfortable completing the square, that's fine. I do have a video that I posted a little while back on how to complete the square, so you can take a look at that. If not, plenty of YouTube tutorials that can also teach you how to do it. I know this isn't everyone's preferred method for solving quadratics, but for this problem, you do need to complete the square if you want to evaluate it by hand. So let's go through the steps of completing the square. For x squared plus 4x, if I wanted to complete the square, I have to take half of 4 and square it, which is 4, because 2 squared is 4, right? So that's my first, and I'll just bracket it off. And now we want to complete the square for y, so we'll have y squared plus 6y, and we take half of 6 and square it, so we'll get 9. Okay, equals, and of course, to balance our equation, whatever we do to the left side, we must also do to the right. So we'll have plus 4 plus 9, which is 13, plus 12, which is 25. Okay, and now because we completed the square, these are going to factor nicely. So we'll have x plus 2 squared plus y plus 3 squared equals 25, right? And from here, we can see that we have pretty much exactly the form we need to find what we want. So we'll know that the center is going to be hk, so it's going to be actually the opposite of these two values. So -2, -3 is our center. And our radius is the square root of 25, which is just 5. Okay, so the radius is 5, and the center is -2, -3. And what that means is when we graph it, and excuse the freehand, not super good at this yet, but we would go -2 over and -3 down. That would be our center point. And then we would go 1, 2, 3, 4, 5, I'll call it like somewhere around here, 5 out in every direction, right? And those are all going to be valid points on the circle, and then we can just kind of connect those. And that's how we would generate a graph. Okay, so now let's take a look at what it looks like on Desmos. Okay, so let's say we have x squared, I believe it was plus 4x, plus y squared, plus 6y, and I always confuse my y and my x there when I'm making this, but okay, there we go. Okay, now there's a few things that we'll be able to identify right off the bat from this. It does give points, and when you're looking at it, you can like kind of snap onto points that are, the most extremes. So the main points we're going to be interested in are going to be the points that exist on the leftmost, rightmost, topmost, and bottommost of the circle. So for example, our topmost, we can see there was -2, 2. So we'll write that down, -2, 2. Our leftmost is -7, -3. Our bottommost is -2, -8. -2, -8. And our rightmost is 3, -3. So 3, -3. All right. And given these points, we can actually find everything we need to know. We can find the radius, and we can find the center of the circle. So first for the radius, actually I just want to test something because I've never tried this before, but I'm thinking maybe Desmos supports this operation. It does not. Okay, so for the radius, basically you just want to find the distance between any 2 points and just take half of it, right? Because the distance between these, not any 2 points, sorry, the 2 opposite points, either the leftmost and rightmost or the topmost and bottommost. In this case, let me just take these. So I just want to know what the distance is. And so because these both have the same y value, we can find the distance by just subtracting the x values from each other. So in this case, we have 3 minus -7, which is 10. So that's our diameter. So our radius is half of that, which is 5. So we'll say r equals 5. And that generates a graph, so let's just turn that off. Okay, so now we know the radius, and to find the center, I'd argue even easier. You really just, so if you notice, the points on the topmost and bottommost and the leftmost and rightmost are joined on like a single line, right? Like these 2 points both are intersected by, let's see, x equals -2. And these 2 points are both intersected by y equals -3. So y equals -3. And we can see by drawing both of those lines, we can get a point right in the center, which is our center, -2, -3. Nice and convenient, nice and easy. You can also, just calculate the center point by just, it's just this y coordinate and this x coordinate, and that gives you -2, -3. So that's how you would evaluate it on Desmos. I just like to give an idea of how to do it that way and also by hand. The reason I think it's important to know and be familiar with how to do it by hand is sometimes they might give you a question where it's like, so let's say we have like a very similar setup, right? But then they'll give you like a plus C, and they'll say, if this circle has a radius of 5, what does C have to be, right? And like, you would have to solve this out. So first, you can say, what your end form is going to more or less look like. X minus h squared plus y minus k squared, let's see, equals, and we want it to equal 25. So, you can complete the square for these, and then you would figure out what value of C it has to be so that when you move it over to this side and you add the numbers that you would add for completing the square, your result is 25, right? So it's questions like that. And there's one other type of question that comes up, and this one I think is like, pretty nice to cover. So let me give you guys that same exact example. So let's say x squared plus 4x plus y squared plus 6y equals 25, right? Nice, simple example. Sorry, I guess before it was equals 13, so that when we wrote it out, it worked out nicely. So they may give you a set of options, right? And I'm not going to write out 4, I'll just give you 2. And they may ask you a question like, on the diagram of the circle, say point CD is on the circle. What's a possible value of C? Okay? So if CD is on our circle and we want a possible value of C, we can really use this graph to evaluate what the possible range for values of X are, right? Because this is like an XY coordinate. So C, we're really asking what possible values of X exist for this function. So let's say it gives you examples like, let me think, what's going to work for this? Let's say they give you -8 and they give you +3. Okay, and of course they'll give you 2 more examples, but I'm only going to go over this because that's all I really need to. It'll be enough to cover the topic. So first thing we want to do is we can identify what our equation looks like. And sorry, let me actually change this to a 2. I realize it's going to work out nicer this way, right? So essentially, I can complete the square and identify what the radius and the center are. Or, I have it here, so I'll just write it down. I know that my radius is 5, and my center is -2, -3. Okay, so we know that graphically, we would start at -2, -3, and we would go 5 out in every direction. So if this is the case, then we know that this point is 5 away from -2, so it's at -7. And this point is also 5 away from -2, so it's at 3, right? So because those are left and rightmost points on the circle, we actually know that those are like our range values for what x can be, right? In other words, x has to be between -7 and +3 inclusive. Those are like the only possible values. So based on that, we would pick B as our answer because we can exclude A because A is not in this range, right? A is less than -7. So that's kind of it for this section. That's really all there is for circles on the SAT, in my opinion. I think that probably covers most of it. Of course, they can give like slightly different answers or questions, but as long as you know that, that's really the bread and butter of solving these SAT questions. So hopefully that helps, and I'll see you guys in the next one.